Jai Hind. My name is Manoj Kumar, Assistant Professor, Department of Computer Science and Engineering, Kumar Garg, Engineering College, Ghaziabad. Today in this video lecture, we will learn about the virtual memory and the page replacement algorithm used in operating system. So this is the table of content that I will cover in this lecture. At first, we will see what is virtual memory and how the virtual memory can be implemented. After that, we will see the concept of the demand paging and what is demand paging, how demand paging can be implemented, or how the page fault can be handled. After that, we will see the different types of page replacement algorithm, FIFO page replacement algorithm, optimal page replacement algorithm, and the LRU page replacement algorithm. We will also see the problems based on these page replacement algorithm in this video lecture. So first, what is the virtual memory? Actually, a computer can address more memory than amount of the physical memory installed on a system. Generally, what happens, in order to execute a particular program or particular process, that process must be completely available in main memory. Okay, and process will be completely loaded into main memory only when the memory size, or you can say that the physical memory size, is greater than the process or program size. There is a situation when our program or process size is larger than the available physical memory. So in this case, how that process will be executed, because the process size is larger than the available physical memory size. So the way to execute such type of process is known as the virtual memory. It means virtual memory is used when the process size is larger than the available physical memory size. And to implement the virtual memory concept, we use the concept of the demand paging. Okay, so this extra memory is actually called the virtual memory, and it is the section of the hard disk. Actually, virtual memory create an illusion of the availability of some extra main memory space, but in actual, this is the part of the secondary storage or the hard disk. Okay, so due to virtual memory, it is possible to execute a program whose size is larger than the physical memory size. So main visible advantage of this scheme is that program can be larger than the physical memory, and virtual memory serves of basically two purpose. First purpose is that it allow us to extend the use of physical memory by using the disk. It means we can increase the size of our physical memory, main memory, by using the space from the disk, but it is an illusion. Okay, that is why this is known as the virtual memory. And second, it allows us to have a memory protection, because each virtual address is translated to the physical address. So virtual memory also provide the memory protection, because every logical address is mapped to a physical address. So this is the basic concept of the virtual memory. Next one is the demand paging. As we know that the paging is a concept of non-contiguous memory allocation method used by the operating system. What we do in paging, we basically divide the main memory into different parts known as the frame. Suppose this is our main memory and this is our logical memory. Logical memory is nothing but the process size. In paging technique, what we do? In paging technique, we divide it equal size of part known as the page. This is page 0, page 1, page 2, and we divide the main memory into equal size of part known as the frame, frame 0, frame 1, frame 2, and frame 3, and these pages are loaded into the frame, and this division is carried out in such a way that page size is equal to frame size. Page size is equal to frame size. Okay, it means each frame is capable to store a particular page. So this is the concept of the paging technique. We divide the logical memory into equal size part known as the page, and we divide the main memory into equal size of part known as the frame, and the page size is frame size. So in paging technique, we load a particular page in the freely available frame. What is the concept of demand paging? In case of demand paging, we load a particular page only when it is required by the CPU. It means whenever CPU generate a logical address, then from that logical address we able to detect that which page requirement it is. Okay, so whenever CPU refer to a particular page, only at that time we load the page. Unnecessary we can there is no need to load the page into main memory. So in case of demand paging, the page is loaded into main memory only when it is referred by the CPU. Until and unless it is not referred by the CPU, we will not that load into main memory. So due to this way, we have some extra space, or due to this way we can utilize the main memory frame in more efficient manner, and we can execute a program whose size is larger than the available physical memory. So this is the concept of demand paging, which is used to implement the virtual memory, because in case of demand paging, a page is loaded into main memory only when it is required. So unless the frame can be so in this way frame can be utilized efficiently. Okay, so this is the concept of demand paging. Suppose this is our main memory, and two processes are there in process 1 and process 2. Suppose when process 1 is loaded into main memory, now suppose memory is full. Okay, now we have to suppose this is the process 2, V2 is executing in the main memory and main memory size is full. Now we have to load the process P1, or we have to execute the process P1. Then what we will do, we will swap out the pages from main memory to secondary and brings the pages of process 1 into the main memory. It means in case of demand paging, the concept of swapping will also exist. Swapping is this is the in case of demand paging, concept page will be loaded only when it is requested, and apart from that we will there is a process swapping. In swapping, the process will be pages will be moved from main memory to secondary memory and vice versa. So demand paging is a combination of paging with swapping. Paging, page are loaded into main memory only when it is required, for that purpose we use the swapping. Okay, next page replacement algorithm. What happen whenever suppose we have a logical memory which has the 4 page, page 0, page 1, page 2, page 3, and we have a main memory with 3 frame 0, frame 1, frame 2. Initially there is a requirement of the CPU referred the page 0, so we loaded the page 0 in main memory. Next time CPU referred the page 1, so we loaded the page 1 in main memory. Next time CPU referred to page 2, so we loaded the page 2 in main memory. So at this situation our main memory is full. There is no free frame available in main memory. Now suppose next time CPU referred to the page 3. So in order to execute the instructions of the page 3, our page 3 must be available in main memory. But since at this time in main memory there is no free frame available, main memory is full. So in this case there is the concept of replacement algorithm come into the existence. It means to load the page number 3 into memory, what we have to do, we have to replace one page to the secondary storage, and we have to make the frame free from that particular page and loaded into the in that frame we will load the page 3. Okay, so it means page 0 will be swap out and this frame will be free, and now this page will be swap in. Okay, so this is the page replacement. But how this decision can be carried out? It means we have here 3 pages, P0, P1, P2. So which page will be selected for the swap out, or which page will be selected for the replacement, so that page P3 can be inserted into the frame. So this decision is carried out with the help of page replacement algorithm. So in simple word, page replacement algorithm are used to decide which page from the main memory will be swapped out to brings the new page into main memory when there is no free frames are available. So this decision is carried out by the help of page replacement algorithm. Generally there are 3 page replacement algorithm. First is the FIFO, first in first out page replacement algorithm. What happen in case of first in first out page replacement algorithm, the page which is loaded first into main memory, that will be selected for the replacement. Okay, let us see an example of this. Suppose this is a page reference string 70 and up to this is a page reference string, and we have 3 frame of in main memory. So if we use the FIFO page replacement algorithm, then what happen? At first, this is the page CPU referred to page number 7. So we have 3 frame. Initially we have 3 frame. So these 3 frames are available. So we load the 7 here. And since 7 is not available in main memory initially, so this is the page fault. Okay. Again, next refer to the 0. 0 is not available in main memory, but 2 free frame are available. So we load the page 0 here. Again, next one is the 1 is referred by the CPU, and 1 is not available in main memory. So page fault will occur, and we will load the page number 1 here. So till this situation, 3 page fault will occur. So in page replacement algorithm problem, we have a page reference string will be given to us, and we have to calculate the total number of page fault using the concept of a particular page replacement algorithm. So in case of FIFO, now when the CPU refer to page number 2, since in this situation no free frame is available in main memory, so in order to insert the page 2 into main memory, we have to swap out any one of them. Then which page will be swap out? So here we are using the concept of FIFO algorithm. So the page which is inserted first into the main memory, that will be selected for the replacement. So page number 7 is inserted first into main memory. So page number 7 will be selected for the replacement. This frame will be free, and we will insert 2 here. Okay. Again, here page fault will be, how many page fault are there? 4. Now again 0, CPU refer to the 0, and since 0 is available in main memory, so when the page referred by the CPU is available in main memory, then no page fault will count. That is known as the hit. So here page fault variable value will not be increased. Next, again refer to the 3, and 3, there is no free frame. 3 is not available in main memory, so page fault will be 5. Now 0 will be selected for the replacement, because among 2, 0 and 1, 2 is inserted first. So 3 will insert here. Now next is the 0. Again, in this situation 0 is not available. Again page fault is occur. So page fault value is 6. 1 is inserted first, so 0 will be inserted at this place. Next one is the 4. Again page fault will be 7. Among 2, 3 and 0, 2 is inserted first into main memory, so 2 will be selected. So this will be the status of memory. After that 2 is referred by the CPU, 2 is not present, so page fault value will be increased. So page fault value is 8. Okay, and among 4, 3 and 0, 3 is inserted into the first, so 2 will be inserted. So here the page fault is 8, and again next value is the 3. 3 is not available in main memory. Again the page fault is will increase. 9 page fault are there, so 0 will be selected. Next 0 is not main memory, page fault will increase 10, and among 4, 2 and 3, 4 is inserted first into main memory, so 0 will be inserted here, 10 page fault. Next 3, so 3 is present in main memory, so no page fault will occur. Okay, so page fault value will be 10. Again 2, so this is hit, this is hit, 2 is also present, no page fault will occur. Next one is the 1. Since 1 is not present, so page fault will occur, so its value will be increased. Page fault count here will be 11. Next, among 0, 2 and 3, 2 is inserted first into the main memory, so 1 is placed here. Again 2 is not now present in main memory, so next page fault count value will be increased, so it will be 12 now. Okay, next one, the 0 is present in main memory, so no page fault value will be increased. Again 1 is present in main memory, so no page fault count will be increased. Again 7 is not present in main memory, so page fault count will be increased, and it will be 13 now. Okay, and among 0, 1 and 2, 0 is inserted first into the main memory, so 7 is placed here. Next 0, now 0 is not in main memory, so page fault count value will be increased, 14 page fault, and among 7, 1 and 2, 1 is inserted first into the main memory, so 0 will be placed here. Okay, again next reference for the 1 is not present into main memory, so 15 page fault count value will be increased, and 1 is placed here. So in this in this problem using FIFO algorithm, total number of page fault will be 15. Okay, So this is another example by taking the 4 frame. Okay, next one is the optimal page replacement algorithm. In case of optimal page replacement algorithm, we traverse the page string, and when the page fault will occur, then we move in the forward direction, and the page which will not be used for the longer period of time, that will be selected for the replacement. Okay, so consider this is our page string from here to here, and we have 3 frame of main memory. So initially up to 701 frames are available. So here is fault occur till this situation, and 701 is the status of memory. Next 2. So in case when CPU refer to the 2, then in this case no frame is available. So which page will be selected for the replacement, either 7, 0 or 1. So how will we decide? With the help of this algorithm optimal. And what optimal page replacement algorithm say? It say that we will move to the forward direction, and among these pages 7, 0 or 1, which will use after a long period of time, that will be selected. So 0 is just referred by 2. Again 1 is referred here, 7 is referred in the last. So 7 will be selected for the replacement. So page number 2 will be placed in case of in place of 7. 7 will be swapped out, and this again, this is the hit. Again 3 here page fault will be 4, page fault value will be 4. Among 3 here the page fault occur. Then in case of this situation, what will happen? We will move from 3 to forward direction, and we will see that whether 2, 0 or 1, which will be used after a long time. So 0, 2 and 1. So 3 will be placed in place of 1. Okay, so page fault will be 5. In the same way, we will continue and count the total number of page fault. After that 0 is present in main memory, then no page fault occur. After that, when CPU refer to the 4 is not present in main memory, so page fault count value will be increased, 6 page fault over there. And after this 2, 3 and 0, which will be used after longer period of time, 2, 3 and 0 will be used. So 4 will be placed in place of 0. Okay. After 2 is present in main memory, no page fault count. 3 is present in main memory, no page fault count. 0, again 0 is not present in main memory, so page fault count value will be increased. It is 7 now, and from here we will move in the forward direction, and we will see that which will be used after a load amount of time. So among these 3 and 2 and 4, okay, so 4 is selected for the replacement. Next 3 is present in main memory, so no page fault count. 2 is present in main memory, no page fault count. 7, 1, when CPU refer to the 1, then page fault count value will be increased, and we will move in the forward direction, and we will see that whether 2, 0 or 3, which will be used after a long time. So 2, 0, 3 is not going to use, so 1 will be placed in place of 3. Now again 2 is the hit. No page fault count increase, 0 is present, no page fault is increased, 1 is present, no page fault will increase. Next one is the 7. So 7 is not present in main memory, so in this situation the value of the page fault count will be increased, and it will be 9 now. So here 0 is 0 and 1, we will move in forward direction. 0 and 1 use, 2 will never use, so 7 will place in case of 2. Okay, so using optimal page replacement algorithm, total number of page fault will be 9. 9 will be the page fault value in this case. Next, this is another example of the optimal page replacement algorithm. Next one is the LRU page replacement algorithm. So when page fault occur, then in case of LRU is known as the least recently used. In case of LRU page replacement algorithm, we will move in the back bar direction, and we say and we will see that which page has not been used from the longer period of time. That page will be selected for the replacement. Suppose this is our page reference string from here to here, and we have 4 frame in main memory. So up to 1, 2, 3, 4 page fault will be there. Next one is the 1 is present in main memory, so no page fault will count. 2 is present in main memory, no page fault will count. 5 is not present in main memory, so page fault count value will be increased. Now we will move in the back bar direction, and we will see that among 1, 2, 3 and 4, which page is not used from the longer period of time. So here 1 and 2 are the recently used, so 1 and 2 is will not selected. Here we will see that 3, so 3, page number 3 will be selected for the replacement, so 5 will place in place of 3. Okay, next one is the 1 is present main memory, so no page fault count. 2 is present in main memory, no page fault count. 3 is not present in main memory, so page fault count value will be increased. Again, among 1, 2, 5 and 4, which page will be selected for the replacement? So we will move from 3 to back bar direction, and we will see that among 5, 1, 2, 4, 4 is not used for the longest period of time. So 4 will be selected for the replacement, 3 will be placed here. After that, 4 is not present in main memory, so page fault count value will be increased. Again, from here we will move in back bar direction, and we see that 5 is not used for the longest period of time, so 4 will be placed on in place of 5. Next one is the 5 is not present in main memory in this situation. Okay, so page fault count value will be increased, so it will be 8, and we will move from here to back bar direction, and we will see that 1 is not used for the longest period of time, so page number 1 will be selected for the replacement, and 5 is placed here. So using least recently used, page fault value will be 8. So this is the concept of all these 3 page replacement algorithm: FIFO, LRU and optimal page replacement algorithm. These are the references, and generally the optimal page replacement algorithm is considered as better page replacement algorithm, because in case of optimal page replacement algorithm, number of page fault are very less. Okay, thank you.